Hello everybody, we are going to be going over our 2.3 notes today. The good news for you is you've already done this before. We talked about slope so many times in your math career and we get to do it again in geometry. So we are going to mainly just focus on slope today. All right, slope is defined as the blank or the blank of a graph. So slope is defined as your rate of change. Hopefully you learned this in algebra. Slope is defined as rate of change. When we're looking at a graph, it is the rise over run of a graph, or maybe the rate of change. I don't know what goes in each blank, but that works, okay? We are going to remind ourselves what the slope formula is. The slope formula is y2 minus y1 over x2 minus x1. When we're looking at slope, it's always the vertical change over your horizontal change. It's your rise over your run, okay? Your rise are your y values and your run is your x values. So what we're going to do is we need to calculate the slope of each line from this graph, and we're going to use rise over run. So I'm going to start with line AB, and here's the dot I'm going to, and here's the dot I'm starting at, okay? So I'm going to rise 1, 2, 3, 4, 5, 6. Remember that the up direction will give you a positive value. And then I'm going to run 1, 2, 3, 4. And going to the right is also a positive value. So this is a rise of 6 and a run of 4. So what I need to do is I need to always make sure that I am giving simplified fractions. These lines are off ever so slightly, and I apologize. You're probably looking at this and saying, it's not perfect. Just bear with me, okay? So AB was a positive 6 over a positive 4. You have to simplify this. So your slope is actually going to be 3 over 2. So that's my slope for line AB. It's 3 over 2, okay? Let's look at line CD. 1, 2, 3, 4, 5, 6. This is also a rise of 6. 1, 2, 3, 4. This is also a run of 4. We already know that simplifying that is going to give me 3 over 2. Let's look at EF. I am going to rise 1, 2, 3, 4. But now I'm going to go to the left, and going to the left is going to give you a negative direction. So we need to make sure that whenever we write our run, that we write it as a negative. 1, 2, 3, 4, 5, 6. So this is a negative 6, okay? So this is 4 over negative 6. 4 over negative 6 will give us a negative 2/3. It doesn't actually matter which number you make negative. I usually make the top number negative, but it doesn't matter. You could have done this 2 over negative 3. All right, let's look at GH, one of my favorites. All right, G and H. I'm going to rise 1, 2, 3, and I don't have to run. So what ends up happening is if you have a 3 over 0, if you were to plug that into your calculator, it's going to give you this. Let's look at it, shall we? 3 over 0. It says overflow error, okay? Essentially, you are not allowed to divide by 0. I think in your calculator, it'll just say error on there, okay? And that's because 0 can never be in the denominator of a fraction. So instead, we need to write our slope as undefined. 0 on the bottom is bad, okay? We don't like that. 0 on the bottom is bad. When you look at JK, what color have I not used yet? Pink. When we look at JK, this one is so off. I'm so sorry. We're not rising any. We're only running, okay? So this one is going to be different. This one is going to be 0 over 2. And then if you were to put that in your calculator, you get 0. 0 on top is okay, okay? You can't be lighter on bottom than on top. You can be lighter on top, okay? So this is going to give us a slope of 0. 0 on top is good. 0 on bottom is bad, okay? Anytime you see either of these two slopes, whether it's 0 on bottom or 0 on top, you must simplify. 0 on bottom is bad. Bottom is bad. You get an undefined slope. 0 on top is okay. That's fine. You're going to make it a 0 slope. You always have to simplify those, okay? It's telling us that line AB is parallel to line CD. How are the two slopes related? Well, if you look at AB and CD slopes, you'll see that they're the same. So we know that parallel lines are going to have the same slope. It also tells us that line AB is perpendicular to line EF. So if you look at line AB and EF, notice that the fractions have been flipped, which is what we call a reciprocal, but the signs are also different. So AB had a positive slope. Whoopsies. Sorry. AB had a positive slope, but EF had a negative slope. So when we have perpendicular lines, we say that they have opposite reciprocal slopes. The opposite refers to their signs. One's positive, one's negative. And then the reciprocal just means that we have a fraction that gets flipped. So we have opposite reciprocal slopes. All right. Now, we aren't going to use the image above for these next two. It says if xy has a slope of 4/5, then we want the parallel slope and the perpendicular slope. So when you have a parallel slope, we just said that parallel slopes are the same. So if it has a slope of 4/5, then the parallel slope will also be 4/5. The perpendicular slope has to be an opposite reciprocal. Right now, my slope is positive. So for it to be opposite, it's going to be negative. And then it was a slope of 4/5, so we're going to have to reciprocate that, and that will be 5/4. When you look at line PQ, it says if PQ has a slope of -5, this is actually -5 over an invisible 1. The parallel slope will also be -5. The perpendicular slope will have to be opposite, so if it was a negative, it's now going to be a positive, and it was 5/1, so now we're going to have 1/5. Okay. All right, so for problems 5, 6, and 7, we need to find the slope, then we need to write the parallel slope, then we need to write the perpendicular slope. So it's essentially what we just did with numbers 3 and 4, but instead of giving you the original slope, we have to find that. And because we were given 2 coordinates, we get to use the slope formula, which is your y2 minus y1 over x2 minus x1. So we always want to start this with our y values. So we are going to do 5 minus 1 over 3 minus -4. This will get me 4 over, this becomes 3 plus 4. So this will be 4/7. So my slope is 4/7, which means my parallel slope will also be 4/7, which means my perpendicular slope will be a -7/4. We're going to do it again. You're looking at your y values first. -3 minus 4 over -1 minus -1. This is -7 over -1 plus 1 is 0. 0 on bottom is bad, friends. Okay, so your slope is undefined. Your parallel slope will also be undefined. And then the opposite reciprocal of an undefined slope is a 0 slope. So remember that an undefined line is vertical and a 0 sloped line is horizontal. Okay, so those are what we consider opposite reciprocals of each other. And then we got this guy. We got -6 minus -6, and that's going to be over -6 minus 6. Woo! This is really 6 plus 6. Whoops, -6 plus 6, which is 0. And then on bottom, this is -12. 0 on top is good, okay? But that means that we have a 0 slope. If we have a 0 slope, that means that we have a parallel slope that is also 0, but then that means that our perpendicular slope is going to be an undefined slope. All right, so that is a bunch of slope review. Let's see what else we have on these notes. Oh, almost done. Very good. Okay, now we're going to use slope. Stop that. All right, number 8 says the results of running... I can't read. The results of a running competition between runner A and runner B are shown in the graph at the right. What does the slope represent? Find the slope for runner A and tell its real-world meaning, and then find the slope for runner B and tell its real-world meaning, and then who won the race, okay? Just an FYI, the person that wins the race runs it in the least amount of time, so just keep that in mind, okay? It's not who goes the furthest, because they should all be going the same distance, but who is finishing the race first, that is the winner. So I'm going to answer that question first, because if you look at it, it clearly looks like runner B finished first. They finished in 6 minutes, whereas runner A finished in 8 minutes. So who won the race? Runner B. All right. What does the slope represent? Well, as a reminder, slope is rise over run. Our rise is our distance, and our run is our time. So the slope is going to represent distance traveled over time. That's what our slope represents, distance over time. We need to find the slope for runner A and the slope for runner B. Okay, so I'm going to start runner A there and end it there. So my rise is going to be 1, and my run is going to be boop, 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 8. Okay, so runner A is going to be 1 over 8. Well, 1 is my distance. So the real world meaning would be that they ran 1 mile in 8 minutes. 1 mile in 8 minutes. Okay, let's look at runner B. I'm going to do that one in green. We're starting here, we're ending here. I'm still rising 1, but now I'm going a 1, a 2, a 3, and that's going to get me to 6. So this is going to be 1 over 6, which means that they ran 1 mile in 6 minutes, which is why runner B won the race, because they ran the same distance in a shorter time. All right, number 9, a wheelchair ramp is to be built at the town library. So as a reminder, a wheelchair ramp is going to look something like this. We're going to have a right triangle. It says if the entrance to the library is 18 inches above the ground and the slope of the ramp is 1 over 12, how many feet away from the building will the ramp start? So if you have a slope that is 1 over 12, that means you are going to rise, looks like rice, rise 1 and run 12. So you're essentially rising 1 and you're running 12. And these are units. So for every 1 unit you rise, you will run 12 units vertically, horizontally, okay? They're telling us that the entrance to the library is 18 inches above the ground. So that means that this over here is going to be 18. How many feet away from the building will the ramp start? We got to find that. My slope is 1 over 12. So if my slope is 1 over 12, then that means that my ramp would have to be 18 over something, okay? And we're going to cross multiply here. I don't know if you remember how to cross multiply, but to cross multiply, you multiply the numerator of one fraction by the denominator of the other, and then you do it the other way. So we have x is going to equal 12 times 18 would be 216 inches. So the ramp will start 216 inches away from the building. In order for us to keep a slope of 1 over 12, remember for every 1 unit you're rising, you're running 18. Or I'm sorry, you're running, okay, let me back up. For every 1 unit you rise, you are running 12 units. Because we are rising 18 inches, we have to multiply that by 12 to figure out our horizontal run. Okay? Okay. All right, let's talk about dividing radicals. When we are looking at geometry, for example, we don't want to have a radical in the denominator, okay? So we have to do this process called rationalizing the denominator, and this is just a method to help us get the radical out of the denominator. And it's really easy to do. What you're going to do is you're going to say, ew, there's a radical in the denominator. I need to get rid of it. We are going to multiply both the numerator and the denominator by whatever is in the denominator. Because I had a square root of 3 in the bottom, I have to multiply both the top and the bottom by the square root of 3. This doesn't affect the top. This is just going to be 2 square root of 3. And then we taught you guys a couple days ago how to multiply radicals together. You multiply radicals together by everything on the outside gets multiplied, goes back on the outside, and then everything on the inside gets multiplied together, goes back on the inside. So the square root of 3 times the square root of 3 is the square root of 9. And you said, but Miss Olmsted, I have a radical in the denominator still. Well, kind of. What is the square root of 9? The square root of 9 is 3. The whole number 3. Okay, remember that this can be broken down into 3 and 3. It's a pair, it goes on the outside, and that's how we get that 3. If you can simplify the whole numbers, you will. You can't do this because one number is under the square root and one number is not. So this is how we rationalize our denominator. The whole reason we do this is because we know that multiplying a radical by itself cancels out the radical. That's what's happening, which is why we do that. Okay, so let's come over here. Let's do the same thing with this one. I have a square root in the denominator. Ew. I'm going to multiply by the square root of 2. This will become 18 square root of 2. This will become the square root of 4. The square root of 4 is 2. So this will become 18 square root of 2 over the whole number 2. I can simplify the whole numbers. This will become 9 square root of 2 when I fully simplify. Okay? When you look at 12, even though you have a square root in the denominator, you also have a square root, the same one, in the numerator. Those cancel, and you're just left with 5. So that one's nice and easy. If you have a square root in the numerator, it doesn't really change anything. We want to get rid of the square root in the denominator, okay? Now, it changes this slightly because now you have 2 things in the numerator that are under the radical. So now I'm going to have to multiply them together to get the square root of 10. This becomes the square root of 4, which we already know is the whole number 2. So this will become the square root of 10 over 2. This is okay. You can have a square root in the numerator. Don't worry about the square root in the numerator. Only worry if you have a square root in the denominator. I'm going to skip 14 and 15 because they're just the same thing again. I'll have these completed on the completed notes, but for the sake of this video, we're going to cut it here. And if you have any questions, please go see your teacher during their normally scheduled tutorial times, and I will see you in the next video. Bye.